Hey, good morning, guys and gals. Mr. Herr here. Happy Monday to you. Hopefully, you enjoyed your weekend. Sorry I couldn't be here to do this with you, but I'll see you before long. Today, we're going to be working on our books, so make sure you have that. Make sure you have a pencil handy. Probably want to have your normal curve chart as well as a handy dandy calculator for you, because we're going to need all those today. I'll keep the video as concise as I can, but with that said, you want to give yourself time to watch this. It will get a little long at times. I apologize. Pause it if you need to sort of get caught up if I go too fast. You guys know how this works. Without further ado, let's go. We're going to talk about binomial approximations today. Specifically, when it comes down to a binomial experiment, you need to know the main ideas. First of all, there are two mutually exclusive outcomes, success or failure. Key phrase there, two outcomes. Yes or no, success or failure, you get the idea. The probability of success never changes, so that means that they are independent. That has no impact. Whatever you get on, say, you're flipping a coin, if you get a heads, that has no impact whether or not you'll get a heads or a tails the following time you flip the coin. Perfect example. And you perform the experiment a fixed number of times. There's no test questions on that, but I also felt like you needed to at least have an understanding of what we're going to approximate, right? Okay, let's give this thing a flip. When it comes to the approximation, we'll do a normal approximation to this binomial experiment. You need to first, though, pass something called the binomial test. This is huge. This screams note card. Well, what is the binomial test? This is N, where it's the number of trials, P, where it's the probability of success, and of course 1 minus P. We are not going to define it, but if you have success and you subtract that from 1, what this is actually the chance of failure. I'm not calling anybody that, just saying it's the opposite of success, right? When you take the number of trials times the probability of success times failure, it has to be greater than or equal to 10 in order for this approximation to take place. If this fails, if it does not pass the the binomial test, sorry for misspeaking, we stop the whole thing dead in its tracks. That'll come up 1 or 2 times. Don't worry, I'll draw your attention to it. Okay. Once it passes the binomial test, then we can find the approximate mean, which is the number of trials, still n, times the probability of success. And we can also find the standard deviation. Well, the standard deviation is the square root of n times p times 1 minus p. But if we look closely, we actually have already completed this. N times p times 1 minus p. What the standard deviation really is, it's the square root of the binomial test. Okay. Again, none of this works if we don't pass the binomial test. Speaking of, slide on down. Will the normal approximation work? A poll of 50 registered voters is conducted in which the respondents are asked whether they believe Congress should reform Social Security. The probability they respond yes is 75%. Right there is probability of success. However, it must be written as a decimal, okay? A poll of 50 registered voters. Well, there's my N value, the number of trials, okay? So let's see if this passes the binomial test. Well, that will be n times p times 1 minus p must be greater than or equal to 10. In this case, 50 times 0.75 times 1 minus 0.75 must be greater than or equal to 10. If this does not pass, we will stop dead in our tracks. If it does pass, then in theory, we can move forward. Well, we run all that together, 9.375 does not pass the binomial test, and then we write in big old capital letters, stop. Okay. Hey, just keeping it real with you, this next one here, it passes. Letter C is actually not a binomial test because they're asking you to record mileage. If I was there, we would do them together, but in the interest of keeping this video short, we're gonna flip forward, okay? And it's okay if you're saying, Mister, I'm not sure where this is going yet. What we do on the next page will really help you out, right? So let's give this thing a flip. Over to page 82. I'll explain all the stuff at the bottom, but let's just chill. According to the American Red Cross, 7% of people in the United States have blood type O negative. Ultimate donor, woo-hoo, you go guys. What is the probability that in a simple random sample of 500 people in the US, fewer than 30 have blood type O negative? If you're saying, what did I just read? Don't worry, I got you, okay? The first thing we're gonna do is set up our binomial test. Well, N is 500 people. That's how many people are in this study. The probability of success in this case is 7%. Be really careful though. 7% is not 0.7. We have to divide this by 100. So that means the probability of success is 0.07. 007, don't forget that decimal point. Now let's run our binomial test. Hopefully it passes. Again, that is n times success times 1 minus success, all of which must be greater than or equal to 100. Well, 500 times 0.07 times 1 minus 0.07. Let's see what that comes out at. Unless I mistyped, which hopefully I did not. That sure looks like 32.55, which is greater than or equal to 10. Put a big old check mark there. That's enough to say that it passes, because I can see the math. Right? Right. Okay. Flipping back to page 81, don't worry, I got you. Now we have to find the mean, specifically the binomial mean. It has a little subscript. Don't panic if you forget the subscript. It's n times p. Well, in this case, that's 500 times the chances of success, 007. Well, my mean, folks, is 35 people. That's what it's expected. Out of 500, we expect 35 to have blood type O negative. We also have to find our standard deviation. The standard deviation is the square root of the binomial test. Again, it said that on the previous page. Don't feel like you have to flip back. That's why I'm here. Well, we already know what that is. Notice we didn't round that. That's important, just FYI. Never round your binomial test, okay? And if you're saying, why, old man? Because if we round it, then when we take the square root, we won't get accurate results. Okay? So I'm gonna take the square root of 32.55. Here you can round because almost every single time you're gonna have a really ugly decimal. So we're gonna go to 2 decimal places. It says 5.705. Well, if we're going to 2 decimal places, the 0, we look at it, behind it is a 5 and above, give it a shove, 5.71. Okay, so there's my new standard deviation. There's my new mean. Ooh, looky, looky. Fewer than 30 people have blood type O negative. So it sure feels like this is X. Specifically, over here, we're gonna rock our Z-score. X minus mu sub X divided by standard deviation sub X. If you're saying, speaking of, if you're saying what's the sub X, that's just so we know it's a binomial approximation. You don't have to have that on a test, but since it's notes, we're gonna do it right, all right? So substitute carefully, but please don't get ahead of me. If you're saying, what do you mean, old man? I know mu sub X is 35 people. I know standard deviation sub X is 5.71. But please pause, because remember, we were saying earlier, it's fine if you don't remember, but this is an approximation to a binomial test. That means we have to leave space for wiggle room, right? That's what it means to be approximate, okay? Here's a rule, we're gonna write this on the side. Fewer than 30, isn't that another way of saying less than? Fewer than 30, less than 30. So for binomial tests, if less than, or implied less than, you get the idea, add 0.5 to x. Well, there's a second half to this. If greater than, sorry for misspeaking. Think about it. When less than, we added 0.5 to x. If greater than, subtract 0.5 from x. I've been doing this a long time, and I still forget this approximation rule from time to time. I remember what to do. Sometimes I just get worked up and I forget to do it. So this says fewer than 30 have blood type O negative. It's tempting to put 30 in here. Don't do it. Because it's fewer than, I'm going to add my 0.5 here. Oh, so the x I'm actually going to use is 30.5 minus 35 divided by 5.71. Well, we've been doing this now long enough. You guys and gals are amazing at z-scores once you get rolling. Run the z-score. Well, that z-score is negative 0.79 because, again, we have to round appropriately. We're going to look that thing up. Negative 0.79. That sure looks like 2148. So 21.48% chance of less than 30, or I guess I should say of fewer than, because that's what the problem said. My apologies. Fewer than 30 of the 500 selected have blood type O negative. You're saying, mister, that's a lot of work. You're not wrong. We're going to do one more together. I know the video is getting a little long, but this one will be faster. You have my word. Okay? Give this thing a flip, if you would be so kind. Over to 83. Here we go. According to the Federal Communications Commission, 70% of all U.S. households have cable television. A random selection of 1,000 households in DuPage County finds that 734 of them have cable. Assuming that 70% of households have cable, what is the probability of obtaining a random sample of at least 734 households with cable from sample size 1,000? First of all, N is 1,000. That's how many homes were selected. We know that. Probability of success, be careful here. It is 70%, which when we convert that, that is 0.7. We got to run our binomial test, which looks an awful lot like this. Substitute carefully. 1,000 times 0.7 times 1 minus 0.7. Terribly sorry. All that must be greater than or equal to 10. Well, let's check that out, right? Sure enough, our binomial test passes with flying colors. 210 is greater than 10. If this was to fail, we stop everything. Dead in our tracks, do not move on, do not pass go, none of that. Okay, let's find our mean. Well, remember that's N times P. In this instance, that's 1,000 times 0.7. You don't need to be a math teacher to realize that is 700 people. Okay, remember our standard deviation is the square root of the binomial test. Again, we don't round that, that's on purpose, so it's the square root of 210. At this stage, though, we'll round to the nearest hundredth, which is 2 decimal places. That gives me 14.49. That's ready, this is ready. Let's do this. Time for our z-score. I know it's going to be x minus mean divided by our new standard deviation. My mean, I already know, is 700. I know my standard deviation is 14.49. At least 734. This implies greater than. If greater than, we subtract a half. It's kind of counterintuitive. So that means instead of using 734, because it's an approximation, we're going to use 733.5. Okay. Now we're ready to run our z-score. Sure enough, we get 2.31. We look this thing up. Unless I'm nuts, 98, apologies, lost my number, 96. However, you think we're done, at least implies greater than. What do we do every time when it's greater than? Oh, we have to subtract from 100. Well, that means 1.04% chance of selecting at least $734 with cable out of 1,000 people. Okay. You're saying, great, mister, now what? Well, we're going to keep it pretty simple. Hopefully those notes weren't too bad. Unless I'm bananas, let's flip to page 85. And that's where we're going to be working on. All right, let me unzoom. Oh, sorry, can't. It's video. On page 85, we're going to cross off B. We'll fill out the mean and standard deviation. Okay. If you do standard deviation, obviously you have to run the binomial test. It will pass, I promise. And then we're just going to run through C as well, A and C. I'll give you a hookup. No sense doing it twice. Okay. Hopefully that makes sense. I'll include the PDF keys to all this. Have a great Monday.